So in this ACT math video, we're going to take a look at distance, rate, and time problems. Sometimes they can get a little bit complicated, so we're going to look at an example today. And this is the problem we're going to look at. So Olivia is driving to the beach. It takes her 9 hours to arrive at the beach. She drives the first 4 hours at an average of 70 miles per hour and drives the last 5 hours at an average of 64 miles per hour. After a few days, she decides to drive back home. It takes her 8 hours to get back home. If Olivia drove the first 2 hours of the trip back home at an average of 72 miles per hour, what was her average speed in miles per hour for the rest of the trip back home? So at this point, you can stop the video and try to solve the problem on your own, or you can keep going and we'll get into working into the solution. So the distance a person covers depends on their speed, how fast they're going, as well as how long they're moving at that speed. In other words, the time. And so the formula D equals RT, or distance equals rate times time, gives the relationship between those three variables. And if you rearrange this formula, you'll end up with two other relationships. In other words, the rate or the speed at which you're going is equal to the distance divided by time. And the other relationship that comes from this formula is time is equal to distance divided by rate. So some students have a hard time memorizing the relationships when it comes to distance, rate, and time. So sometimes what we can do is we can use what's called a distance, rate, time pyramid to help us memorize the formulas. All you do is whatever you want, you just put your finger over what you want, and what's left over is the formula for it. So let's say I wanted to find distance. All I'm going to do is take my finger and put it over distance, and what's left over is rate times time. If I want to find the rate, I just put my finger over the rate, and it tells me that rate is equal to distance over time. Now, if I want to find the time, I just put my finger over the time, and it tells me that the formula is distance over rate. And so the distance, rate, time pyramid makes it easier to know the three relationships relating to three variables. So when you initially read this problem looks very hard to do, but it's actually pretty manageable if you separate it into parts. So what we're going to do is we're going to separate it into 4 different parts of the trip. We're going to cover the first 4 hours to the beach, the last 5 hours getting to the beach, the first 2 hours getting back home, and then the final 6 hours getting back home. So now let's look at the first leg of the trip. So for the first leg of the trip, she drove the first 4 hours at 70 miles per hour. So we can get the distance she covered during that leg. And so distance is going to equal rate times time, which is going to be 70 times 4. And that's going to give you 280 miles. So for the first leg of the trip, she traveled 280 miles. For the next leg of the trip, she drove the last 5 hours at an average of 64 miles per hour. Once again, we can get the distance for that. Distance is equal to rate times time. That's going to be 64 miles per hour times 5 hours. That's going to give us 320 miles. Adding those together, it looks like to get to the beach, the total distance covered is 280 plus 320, which is equal to 600 miles. So for the whole leg of the trip, so the entire trip to get to the beach is 600 miles. And we'll use that when we go on the return trip. So now let's start making our way back home. So for the first 2 hours back home, the rate was 72 miles per hour for 2 hours. So once again, we can get the distance for that. Distance, once again, is rate times time. Which is 72 miles per hour times 2 hours. That's 144 miles. So the first leg of the trip back home covered 144 miles. Now we need to figure out what's left over from this trip. So keep in mind, we have a 600-mile trip. So in other words, the miles that are left to drive, this is a 600-mile trip. We've already driven 144 miles. So in other words, that's going to leave 456 miles left to travel. Now keep in mind, we've already driven 2 hours and it took her 8 hours to get back home. So the amount of hours that are left is going to be 8 hours getting back home minus the 2 hours we've already traveled. So now there's 6 hours left to drive. And we'll keep that in mind. So now I'm going to delete this information and I'm going to put it at the bottom. So now we can figure out what with the average speed she went for the rest of the trip back home. In other words, the last 6 hours back home. And rate is equal to distance over time. And we know the distance she has left to cover is 456 miles. Divided by the 6 hours she has left over. And that's going to give you a speed of 76 miles per hour. So for the last 6 hours or the rest of the trip back home, her average speed was 76 miles per hour. The answer is E. So go ahead and visit the site mathonthefly.com, where we have over 100 ACT math worksheets that cover a variety of topics. And while you're at it, go ahead and join our mailing list for updates and what's going on. And we also offer an ACT math book that has over 1,100 problems with complete solutions. It's a good guide for the test. And with that being said, hope you liked the video, and I'll see you in the next video.